part 1 of this video, towards the last element, was that we were given that p of this cubic polynomial had a perfect factor x plus 2, which meant that x minus 2, when it was put into the polynomial, it was producing a remainder of 0. So that gave us one equation. And then they also told us that x plus 1 leaves a remainder of 2. So when we put p of p negative as an input in the cubic polynomial, it produced a remainder of 2, which gave us our second equation. And solving this and this simultaneously, it produced us the values of a is equal to 3 and b is equal to negative 4. However, if you had to do it all the way through long division, then this would have been a nightmare. Let's say you put this cubic polynomial inside the long division, you divide it by x plus 2 must produce a remainder of 0. Now, so you divide this term by x, so you get ax squared, so this becomes ax cube, and this term becomes plus 2ax squared, and then you subtract them both, so this gets cancelled and this becomes 5 minus 2a x squared. Right now you copy down minus 4x, so now you divide this term by this, so you get 5 minus 2a x x, right? So now when you multiply x with this and then you multiply 2 with this, so you get 5 minus 2a x squared and then plus 10 minus 4a, because 2 times 5 minus 2a is 10 minus 4ax, and then you subtract this and then you subtract this in order to obtain this minus 4 minus 10, which you could also by the way rewrite as minus 14. I will just put it here. So this could also be rewritten as minus 14, right? And then you multiply it by this in order to get this, and then final remainder would have been b plus 28 minus 8a, which you would equate it to 0 because we are told that x plus 2 is a perfect factor. So that gave us the equation b is equal to 8 minus 2a, which was same as what we had obtained through factor theorem, right? Now and similarly you would do so this gave us the first equation, and then you would do the second equation by dividing it by x plus 1, and whatever remainder you got in terms of a and b, you equate it to 2 in order to get the second equation, and then you solve it simultaneously. But do you see how difficult that becomes? However, this part of the video is not going to be about factor theorem. We leave it for the next lesson. We are now going to talk about the examiner traps. Okay, so the first one is going to be that if you have a quadratic polynomial x4 plus 3x squared plus 2, students forget that there is a 0x cube and a 0x involved in it as well, because if you are dividing it by x minus 1, then you get so when you multiply it by x cube, then multiplying minus 1 with this leaves you a negative x cube here, right? So make sure that you do not write this. Instead you do it like this one and this one, and you put, I'll use another color in order to make distinctions, you put plus 0x cube and plus 0x, right? So that it becomes easier for you. Now, trap number 2 is that students usually subtract wrongly, right? They do not subtract all the terms. That once you put something here, just like this one, you must put a negative sign here. And whenever you are doing long division, just like we had been doing in our earlier cases, we would change the signs. This becomes negative, this became this negative became positive, this positive became negative. So you have to subtract because you do the same. So for example, 35 divided by 4 is 8 times 32. Now you subtract it as well, right, in order to get a remainder of 3. So you do the same here. So that's the trap number 2, that you do not do the subtraction properly. That's the most common error as per the examiner reports. Now, trap number 3 is that the remainder is too large a degree. Like I said earlier in the last lesson, that this the remainder must the degree of remainder must be lesser than the degree of the divisor. I wrote it somewhere here. Yeah. So just like we found out here that the degree of the remainder, which is degree 1, is less than the degree of the divisor, which is degree 2, right? So that's a must. And now trap number 4 is that you are rushing. Division is mechanical, so accuracy wins. So you are not just trying to do it very quickly, rather you are doing it intelligently and very carefully and not making any errors. Now towards the, so what was the takeaway in these two lectures, the previous one and this one? So today's takeaway, right? So polynomial division is just like number division, right? It's similarly if you were dividing 35 by 4, right? Now every division is going to give you a quotient and a remainder. So you get a quotient here, and when you divide this polynomial by a divisor, you get something here, or you write down, so quotient I will write down as q of x, this polynomial or dividend is p of x, so this becomes r of x or d of x. I will call it d of x. So d of x times q of x, and this gets subtracted, so you get a remainder. So this is some function. So the degree of remainder has to be, so the degree of remainder of x has to be less than the degree of the divisor of x, right? So it always produces a remainder, which could also be a 0, and a quotient q of x whenever you divide a dividend p of x, a polynomial, by a divisor d of x, right? Now remainder carries information, right? So if the remainder is 0, that means that this divisor is a perfect factor or is a factor. That's one and the same thing. Now factor theorem. So from here onward, in the next lesson, we are going to begin with factor theorem, which by the way I did towards the end of the last video. The last question that I did, and which I'm showing here as well, this was factor theorem, and we are going to do it in much more detail in the next lesson. Now suddenly the questions which look impossible that I was showing you through long division, they just become one-line solutions, and we are going to do it next. Now if you have any queries, you can reach out to me on my WhatsApp, which is +92 329 3028 485 or 3028 485, or if you want to follow us on Instagram, where I am relaying all the information, you can follow us on our handle @easy talim, EASETALEEM. I'll see you in the next video.